Good morning, everyone. Welcome to this session on modern messaging with RabbitMQ, Spring Cloud, and Reactor. A few legal stuff about myself. My name is Arnaud. I'm a software engineer at Pivotal. In the RabbitMQ team, I work on the broker itself and some extension and client libraries. My background is mainly Java and Spring stuff, Spring framework and projects of the portfolio. So here's the agenda. So we're gonna have an update on RabbitMQ, new stuff in the last version. Then the bulk of this presentation will be how to use RabbitMQ inside the Spring and Reactor worlds. And we're going to end up with tips to have the best RabbitMQ development experience, so tips around design and how to install correctly RabbitMQ on a workstation and so on. So first, what's RabbitMQ? It's a messaging broker. It supports different protocols, AMQP protocols in two main versions, MQTT, STOMP. It's quite an old project. It started more than 10 years ago. It has a broad ecosystem and including Spring support. It provides also support for clustering, height availability, built-in monitoring thanks to a web management UI and a REST API. The ecosystem is mainly made of clients from different platforms to speak with the broker. We, at Pivotal, we support different clients, so Java, Erlang, and .NET for AMQP 0.9 clients, and also a JMS connector. There are tons of community-led clients, mainly AMQP clients again, in all the popular languages. And there are also higher level clients like SpringMQP, RabbitMQ in the .NET world, that usually builds on top the lower level clients. One slide about the AMQP model, if you're not familiar with it. So when you are using AMQP, you publish messages to exchanges. These messages are routed to queues, and this is where you can consume your messages from. There are routing rules between the exchanges and queues. We call that bindings. Okay, so this is all defined in the AMQP specification, AMQP 0.9. And we call all these exchanges, queues, and bindings between them resources or the topology of your cluster. So if you're not familiar with AMQP, try to remember this. We publish to exchanges, routing rules, bindings, to route the messages to queues, and then we consume from these queues. When to use Rabbit? In typical enterprise integration scenarios, when you want your different applications to communicate with each other, and when you want typically asynchronicity and buffering between upstream and downstream applications. Okay, so you can have your downstream application down for maintenance or because it's failing, but upstream applications are not impacted because they just communicate with the broker, and the broker will buffer messages. We have two typical use cases for the type of workloads, high message rate, low latency use cases. These are the kind of historical use cases for messaging broker. And we have also the typical IoT use case when we don't publish as much messages as with the latency workloads, but we have many connections, many clients, like thousands, hundreds of thousands even. And these clients are sensors, cars, or whatever. An update about new stuff in the latest RabbitMQ version 3.7. So it was released almost a year ago. We are trying to focus on the operation part and also reliability. For example, we try to make multi-tenancy even more isolated, even better by separating message store per vhost. Vhost is the kind of virtual host or the multi-tenancy feature inside Rabbit. There's a new configuration format, new peer discovery mechanism, and also support for the proxy protocol support. There are other things, but I'm just trying to focus here on the last 3 items. First, the configuration part. So maybe some of you are familiar with the configuration of Rabbit. Maybe some of you have thought with this configuration. It's the configuration by default, the historical one, is made of Erlang terms. So Erlang is the programming language RabbitMQ is written into. And these are, Erlang terms are just kind of objects for Erlang. So there are lots of brackets, curly braces, strange strings coated with weird characters. So it's not very easy to work with, even if you are familiar with Erlang. But it's also very difficult to generate for if you want to automatize anything in your installation. So this format is still valid. We call it now the advanced format. And the new configurations format is just made of key value pairs. So it's a simple text-based format. So it's much easier now to generate and parse this one for humans and for machines as well to generate configuration. And there's even validation against a schema. So we even get better error messages in case of something wrong in the configuration. Another new thing in 3.7 is the peer discovery mechanism. So what is it about? It's when you have an existing cluster and a new node want to join. So it needs to discover its peers, the other nodes. So there are different ways actually to perform this discovery. We could use only CLI tools or a static configuration file before, but we introduced a peer discovery phase into the boot sequence of Rabbit. There's a plugin mechanism, so this is extensible. And we currently support many different platforms like AWS or Kubernetes, service registries like etcd and console, and also DNS record. So the point here again is for operations, for make the installation and the deployment of cluster much easier with this new discovery and extensible mechanism. It's quite common to use a proxy in front of Rabbit, so a proxy like HA proxy or ELB in AWS. Something operations complain quite often is you actually lose inside the broker the original client IP. So you don't really know where your client is when you look it from the RabbitMQ standpoint inside the management UI, for example. Because for each connection we're going to have inside to the broker, we're going to see as its origin the IP of the proxy. So it sounds a bit silly, but this is quite a concern in some deployments. There's a solution for that. So that's the proxy protocol support. You must have a proxy compliant for this. So when a new connection will come to the proxy will actually forward it, obviously, to the backend server, but it will actually add a few information in the first frames of the TCP connection. And inside this information, you can have the IP address of the client or its certificate if you are using TLS. This kind of information. And the backend server must know about that. It will gather this information, make anything it wants with them, and then just handle the traffic. Okay. So we added this support in Rabbit to forward all this information. And now you can enable, because it's an opt-in, you can enable proxy protocol support for your different RabbitMQ connector and supported protocols, and actually see the real IPs, real informations about your clients before the proxy. A few words about the roadmap now. So this is all work in progress. We don't promise anything here. We are working on bringing OAuth support inside Rabbit. Most half of the work is already done. We are implementing a new queue type, what we call Quorum Queue, and also we're going to work on handling network partition better in the next major releases of Rabbit. So this feature will end up in 3.8 or 4. We don't know yet exactly. Focus on the new Quorum Queue implementation. So a new type of queue. We are going to try to provide a more consistent queue implementation with these new Quorum queues. And we trade latency for throughput in this case. The point here is to build something solid and that anyone in the industry can understand, especially about the semantics of failure. So the Quorum Queue, this Quorum Queue implementation is based on the Raft algorithm. So Raft is a consensus algorithm with well-defined semantics regarding the whether a write operation has been accepted by a consensus majority of nodes and so on. It's Raft so has well semantics, and it will be much easier to communicate what the trade-offs are, what are the decisions we are making in case of failure of part of a cluster nodes. So we built our own Raft library for this, and our implementation is Jepsen tested in some different at some different layers. So Jepsen is a toolkit to detect failures in deboosted systems. So it's going to simulate some workload and create some network partitions and so on. So we created our own Jepsen test for this, and we consider making them part of kind of regression test suite. So the point here is to alleviate actually some shortcomings of the existing mirrored queues implementation. And we are trying also to improve the network partition handling. So right now in RabbitMQ, how the broker will react to network partitions really depends on Nisia. Nisia is an internal Erlang database. It comes with the Erlang runtime. And RabbitMQ requirements don't always align perfectly with Nisia in terms of network partition detection, what we call partial partition handling. So we, even if a lot of the code base depends on Nisia, we're going to try to remove this dependency, and the expected outcomes here are to a better resilience to network partition, and make it easier to choose between availability or consistency when it comes to network failure. Okay. So we just starting here the experiments. Now the Java client, so this is SpringOne. If you are using RabbitMQ somewhere in your Spring stack, you are actually relying on the RabbitMQ Java client. So this is one of the officially Pivotal supported client. It's after a poll we made, it's the most used client actually. It supports AMQP 0.9.1 and also RabbitMQ extensions. It has built-in support for automatic connection recovery. We maintain currently 2 branches, so 4 which support Java 6 and 5 which supports Java 8 and more. It used to ship with the broker with a big release cycle, but it's no longer the case for about 2 years now. It's completely dependent. What's new in the Java client, so new stuff from the last couple of years. Connection recovery, automatic connection recovery is now enabled by default. We have logging support. There was a really strong no dependency policy inside this client, but we have at least now 1 mandatory dependency, which is SLF4G for logging. We have also a few optional dependencies for metric support, like drop wizard and micrometer. We introduced metric support in version 4. We also introduced NIO connector. So there's the default connector when we use blocking IOs, but you can switch to NIOs. It's an opt-in again, and there's no external dependency. We don't rely on something like Nelly. We use the bare JDK API in this case for NIO, and we have also fancy feature for topology recovery. In the version 5 branch, so we require now Java 8, and we revamped a bit the API to introduce Lambda-oriented APIs, especially for message consumption, to have something more opinionated in some cases. There are 6 or so callbacks regarding consumption. You don't always implement all of them, so we have shortcuts in methods which are Lambda-oriented. And we also added asynchronous RPC. So here the point is actually to have something for a bit more reactive, and we are actually building the Reactor extension on top of this asynchronous RPC. Okay, so that's it for this update. So now let's see where you can use RabbitMQ inside your Spring and Reactor stack. So we will cover all these projects, and because they all integrate in some way with RabbitMQ. This is not meant to be comprehensive, obviously. So let's start with SpringMQP. So SpringMQP brings Spring concept to MQP. For example, the template approach, focusing on sending, publishing messages, and don't really care about resources. This is handled by SpringMQP, focusing on what matters for your application. Pojo programming. So you don't care about the serialization, whether you are using JSON or XML on the wire. It's all handled by configuration by SpringMQP under the cover, so you can use plain Pojos from your business model inside your application. There are more advanced features like Queue affinity. if you want to consume as close as possible in the owning node of a queue in your cluster. SpringMQP can compute this automatically. SpringMQP has also built in its own connection and topology recovery mechanism. Sophisticated message container listeners with a lot of options regarding threading, acknowledgement, transactions, and so on. So under the covers, SpringMQP uses the RabbitMQ Java client. Spring Boot. So what's the RabbitMQ support in Spring Boot? So there's auto configuration. As soon as you have the appropriate dependencies on your class path, Spring Boot will create some beans like the connection factory, a RabbitMQ template from SpringMQP. It will register your asynchronous listeners if you declare them as Spring beans. And it will also plug the Java client metrics on Spring Boot main metric system. So let's see this in a small demo. So this is a simple Spring Boot application that I generated from the initializer online. I just added a few dependencies and a few settings. So here's the code. I get the context. From the context, I get the RabbitMQ template. So there's nothing to configure in this case. This is all auto-configured. And I send a message every second. My configuration is here. I configure my queue and one listener. And I just listen on my messages here and just output something on the body of the message on the console. Here, I can, let me go first to see what's going on inside Rabbit. So this is the RabbitMQ web management plugin. So this is my connection here from my Spring Boot app and the two channels, one for sending, one for consuming. I can go to the metrics. So this is the list of all the metrics inside my Spring Boot app. So now there are a few of them that belong to the RabbitMQ Java client. For example, number of channels, number of connections. And you can have some details about them. For example, number of messages you published since the beginning of the application, since the startup of the application. And there's also Prometheus support inside Spring Boot. So Prometheus is quite a popular backend, metrics backend. And all the RabbitMQ metrics are also exported automatically to Prometheus. So this is all plugged together. You don't have much to do to benefit from all these metrics and information about your RabbitMQ part inside the app. Reactor. We created a few months ago, last year, if I remember correctly, the Reactor RabbitMQ extension. So the point here is to provide a functional and reactive API for Rabbit, and it builds on top Reactor core and the Java client. This extension is a bit opinionated. The main use cases are resource management, so creating your exchanges, queues, and bind them together, publishing a flux of messages, a Reactor flux, and consuming messages as flux. So here, this is an example of the Fluent API and Fluent and Reactive API to manage your resource. When you want to send information, messages, or manage your resource, you use a sender. And from this sender, you have different methods to manage your resources. So I declare an exchange, and then I declare my queue, I bind them together, and all of this only happens when I subscribe to the Flux, just as usual with Reactor. With this sender, you can also send messages, a flux of outbound messages. So this flux can come from anywhere. It just needs to be some outbound messages. You just pass in this flux, and you can get notified on any error and start publishing also. We support also publisher confirms. So this is an extension in Rabbit whereby you can get confirmation that the broker has taken your message into account. So here you pass in again your flux of outbound messages. You get a flux of outbound messaging results, confirmation, whether your message has been accepted by the broker or not. Regarding consumption, nothing fancy. We create a consumer, a receiver object, and then we can consume from it from a queue, and we get a flux of message. So it can be infinite. It will be typically infinite. Other goodies, in terms of consumption, we support different flavors of acknowledgement. So the previous one was with only automatic acknowledgement, but we support all the options supported in RabbitMQ. There are features like retrying when something fails in publishing. If your network is flaky, connection failure is handled. And there's also RPC, request reply, with the mono Reactor API. Okay. There's another place when we can use Reactor and RabbitMQ together. This is for monitoring. RabbitMQ exposes an HTTP API, and hop is one client. It provides a POJO API basically to get information, monitor your RabbitMQ cluster. So it's meant for administration and monitoring, not messaging this time. So inside hop, there are two clients. The historical one is blocking based on Spring Web REST template. And we introduced a new one, which is based on Reactor native. And in this case, it's pretty much the same API, all the same features as the other one, but with Flux and monos. Both will hit the RabbitMQ management plugin. So you typically use one or the other client. So using hop inside your application can be useful if you want to build a specific dashboard. That's even more convenient if you are using the new Reactor-based one, because you have the Fluent Reactive API with all the map reduce operators that can help you to easily compute any information that you need on your dashboard. We can also use RabbitMQ inside the Spring framework itself in a specific module, inside the Spring WebSocket module. So WebSockets are there typically to make your web pages more dynamic and reactive. This is good for low latency, high frequency, high volume use cases like chat rooms or even financial stuff. And the way messages are passed inside between the clients and the containers, the web container, is based on a broker abstraction in Spring. Okay? So there's a local abstraction, in-memory abstraction, and also another one based on STOMP. So what does it mean? Imagine that you have your web application hosted on one container instance. Browser 1 will publish updates or events for topic 1. Browser 2 comes up, can register to topic 1 and get the updates directly from the web container. They are pushed from the container. Okay? So this is typical WebSocket stuff. All the topic communication is based on this local broker implementation, in-memory channels, basically. This works, but there are limitations. Just imagine that you have different nodes for your web container, for failure, for scaling. If you stick to the local broker, this won't work, because if you are interested in topic 1, there will be typically 2 instances of topic 1, one in the first node and one in the second node, so they can't see each other. Okay. We can illustrate this with a demo. Let me stop this. So I'm using here the Spring WebSocket app written by Rosen Stoyanchev. So this is the configuration here. I'm starting in the background 2 instances of Tomcat, so one on 8080 and one on 8081. So we can connect to both of them. Here. It happens sometimes. Okay. Here. Oh, sorry, this is the wrong port. So I am on 2 different instances. I logged in with the same user, and if I trade some stocks, my dashboard is updated automatically. So if I, for example, here buy some shares and trade them, it's going to be updated on the first instance, but it didn't change on the second instance. Okay, the second instance hasn't been updated because of what we've just seen on the slides. We have 2 different instances of the local broker, and they can't see each other. Same thing here. If I buy some stocks, only one of the tab will be refreshed. So this is because of the issues here. So that's why there's another implementation inside Spring WebSocket, which is using STOMP. So in this case, all events related to WebSockets will be relayed to a backend STOMP broker. So we're lucky RabbitMQ supports STOMP. So this way you have one centralized place for your queues, for your topics, your STOMP topics. And if you publish to topic 1, you will be able to consume from this topic, and this is the exact same instance inside the broker. So we can stop the app. And this is the configuration, the Spring configuration. I was using the default simple broker, and I can enable the STOMP broker. So this is all about all Spring here, quite typically, because I'm just changing some configuration, and Spring framework will actually absorb the difference between the infrastructure. Okay, there's no code change. It's just a matter of configuration, the Spring philosophy. Okay, so let's start this again. So I recompile and restart the two instances. So the thing has changed here, fully, but now they are connecting to, but they are not directly connected to Rabbit. The application is, and if I trade now the stocks here, both have been refreshed. Okay, they are both listening on the same topic. And sending to the same topic. So this is now the exact same topic inside the broker. We can also try here. Okay, again, it was updated and refreshed on both. Okay, so another place where you can use RabbitMQ, in this case with the STOMP protocol. So now let's get into Spring integration. Spring integration is meant to make your application agnostic to your messaging technology, typically. It can be any kind of messaging technology. So there are inbound and outbound AMQP adapters inside Spring integration. So you can publish or consume messages. There are also gateways. So more for request reply in this case, inbound and outbound. Spring integration is all about channels. And there's an AMQP backed channel implementation. All of this is based on Spring AMQP. That's the foundation for higher level modules like Spring Cloud Stream. Speaking about Spring Cloud and Spring Cloud Stream, Spring Cloud Stream is much more opinionated than Spring integration. It integrates with Spring integration and Spring Boot to easily write applications that get messages, process them with application logic, and then can post or publish messages, these transform messages to somewhere. Okay, typically over Spring Cloud Stream applications. Where does RabbitMQ fit here? So RabbitMQ can handle the messaging part, make your application, your Spring Cloud Stream applications communicate with each other. So it's what we call the binder inside with the Spring Cloud Stream vocabulary. Okay. So there are many good stuff inside Spring Cloud Stream in the RabbitMQ support. For example, partitioning. There's no native partitioning inside RabbitMQ, so just natively. So here there's a software implementation that can help you scale easily your application. Quite nice features. And then one step further, it's Spring Cloud Data Flow. So here, this is the runtime with Spring Cloud Stream, this is more of a framework in a way. And here, this is the runtime. You can write your Spring Cloud Stream applications and then deploy them on with Spring Cloud Dataflow. Spring Cloud Dataflow can take care of the deployment, undeployment, and also scaling them, all of this. And RabbitMQ will be again the messaging middleware here to make your application work together, communicate with each other. And the interesting part here is to be able to deploy on different platforms thanks to Spring Cloud Dataflow, like Cloud Foundry, Kubernetes, Mesos, or Hadoop with Yarn. There's still one place where you can use RabbitMQ into Spring Cloud. It's the configuration part. If you are using microservices, you typically have a bunch of them, and you cannot configure these microservices application with simple configuration files, because you would have like too many files, configuration file. So with the Spring Cloud config module, you can write all your configuration inside the Git repository and make this configuration available on HTTP with Spring Cloud Server, Spring Cloud config server. And when your application will start, they will get their $curly braces info from the Spring Cloud config server through HTTP. That's the bare minimum you need for a large microservices architecture, a configuration server like this. You can go a bit further and make your application react to configuration changes. So you can change your configuration, push it on your Git repository. If you register, you can register a webhook that will post the information on Spring Cloud config server. Thanks to Spring Cloud Bus, the configuration change will be pushed on some RabbitMQ queue where applications are listening. So the application can consume configuration updates and make anything they want after these changes. Okay? So you can use the refresh scope with the @refresh annotation, and these beans will be kind of recreated. Okay? So that's the ultimate step here when you you not only get information from your Spring Cloud config server, but also react to configuration changes. Okay, so that's it for our tour of Spring and Reactor, and how Spring and Reactor can work with RabbitMQ. Let's see some tips for those developing every day with RabbitMQ. We'll see how to easily install RabbitMQ. It's not always easy, especially when you're a beginner. We're going to have a couple of slides on typical pitfalls to design correctly your application, and we'll see also how to simulate some workloads with PerfTest. So before installing RabbitMQ itself, you need to install the Erlang virtual machine, just like for Java, basically. It works pretty much the same way. On server, you will typically use native packages like debs or RPM, but on workstation, there are other options. I typically use kerl. Kerl is a script, a shell script that can compile and install the Erlang SDK. Why not using packages or installers to install Erlang? Because there are many minor versions or patch versions for Erlang, and packages are not always up to date. And maybe you also want to use a very specific patch or branch on GitHub. So it can be useful to compile your own SDK. And maybe you also want to have different version of Erlang on your laptop. So then comes kerl. So think of kerl as some kind of SDK man for Erlang. So the first command here, compile Erlang from GitHub with this tag, so version 20.03.04. The second 20.034 is actually the ID on your laptop. So it will take typically a few minutes, like 10 or 15. And then with kerl, all your builds are managed, and you can list them, you can remove them, and you can also choose a default one, choose one for this specific shell instance. That's very useful if you are strongly working with Rabbit or Erlang systems. For Rabbit, same thing, you can use native packages that we provide to install RabbitMQ on your workstation. I will recommend the generic Unix binary for your laptop or workstation. So it supports Linux, Unix, and macOS. And the point here is to be able to have several versions of the broker on the same machine. So it's just an archive that you get and unzip, and that's all. Okay, when you can remove it, you can have like many versions of it on the same machine. So with these tips, it will make your development much easier. If you want to test upgrade scenarios, for example, migration scenarios, you can easily switch between the version of Erlang and RabbitMQ directly on your laptop, okay, before trying on your QA environment or dev environment. And with this, you can still have several nodes and then cluster them together on the same machine again. So you can test easily and quickly very advanced scenarios. Now some tips. First about consuming messages. When it comes to consumption, people can choose to use auto-acknowledgement. So if you are using that, be careful to have fast consumers. It means that if you don't have fast consumers and you are using auto-acknowledgement, the broker will end off all the messages to your consumers. And then if your consumers cannot keep up, they're going to buffer themselves in memory the messages. Okay. So it will typically make your consumer application crash. So to avoid that, you can use acknowledgement and set quality of service properly. So what's quality of service? It's the number of unacknowledged messages that you can have in your application, in your client application. So here you just say, as a consuming application, I can handle like 10 messages at one time. And when I acknowledge one of them, give me another one. Okay? So it's some kind of flow control here. So you will avoid overflowing in this case and make load balancing much easier between your consumers, okay? Because the broker will typically use all of them. Okay? About the value itself, it really depends on the scenario. So for QS, you can use something not too small. Don't use one, because you will not use your consumers a lot. You will underutilize them. And if you set large values like thousands, it can lead to actually the auto-acknowledgement issue, because if you cannot keep up, you're going to have a lot of messages on your application side. So for example, in Spring AMQP, we set up the default value for QS to 250. That's just a value that works for many cases. It used to be 1, which was not good. Something that comes quite often too is scaling with Rabbit. We observe sometimes the big giant queue anti-pattern. So you have a cluster with only 1 queue. You have to know that a queue is basically an Erlang process. An Erlang process is a very lightweight Java thread. And one Erlang process will be typically handled by 1 CPU. Okay? So if you have just a few queues in your cluster, maybe you are not using all your CPUs on your server. So you need to scale with different queues by increasing the number of queues. There are different options. We provide some plugins like the random and consistent hash exchanges. These are kind of load balancing exchanges that distribute the messages on different queues. There's also the sharding plugin, which presents one big queue, which is actually logical and backed up by real queues. And you can also look at Spring Cloud Stream, which provide a partition implementation that performs as well as the other native or plugin solutions. There's also a useful plugin that ships with RabbitMQ natively. That's the top plugin. You can enable it, and then you can go to the appropriate tab in the web management UI and have some insight about the bottlenecks inside your system. At last, how to simulate your workload. So everything is set up, your application is set up, you're pretty sure that your design is good, but you want to simulate your workload. It's not that always easy. So we came up with this PerfTest tool that we use ourselves. So it's a Java tool, it's based on the Java client. We use it extensively for our long-running environments and also for our use case-oriented workloads, which were, for example, mentioned this morning in the keynote. So there's a bunch of features inside PerfTest. You can configure the rates of your messages. It can handle the topology creation. You don't have to create manually your exchanges and so on. It calculates the message latency, the time between the message is sent and consumed. You can configure some latency also in the consumer part. You can configure the size of your messages or also get the content of your messages from files to have real messaging flowing in the test. It supports also TLS. It can work on flaky networks because it supports connection and topology recovery. There are options regarding threading. We'll come back to this later. Recently, we introduced support for micrometer, so you can actually have information about your running PerfTest instances and try to correlate them with the information you have from your broker. We'll see more about that later. And there's also a Cloud Foundry template project if you want to easily test, use PerfTest on Cloud Foundry. A few examples. Simple little throughput workload, 10 producers which produce each 1,000 messages per second, 10 consumers, and you want to balance this on 10 queues. So nothing fancy in this command line. There's the rate option, the number of consumer and producers. We have these 3 options for queue naming. So first the pattern. and then the number from 1 to 10. And the number of the queue can be replaced, can be used inside the pattern. So this is one of the most simplest, the simplest test here that we can run. A few years ago, we started simulating IoT workloads. And it happens to be quite challenging, actually, on the PerfTest side. So this is when you want to simulate a lot of connections, like hundreds of thousands. The point is to test the broker, put pressure on the broker, but it puts also pressure on the testing tool, because simulating all of this is quite demanding. So we could run out of memory of thread or file descriptors, and we needed serious optimization inside PerfTest to avoid using tons of instances, like hundreds of instances to simulate thousands of connections. So let's see how it goes with a small IoT workload. We have only 100 producers. Here the rate is quite small, 1 message every 5 seconds, sorry. So it's not a rate, it's more a frequency. We don't want all these producers to start at the same time. We don't want some kind of storm of messages. So there's a ramp-up period. And in this case, we have 300 consumers, and all of this is balanced on 100 queues. So it's quite close to what we have seen previously, except for the beginning here. So there's no longer a rate. There's the publishing interval option. So we want to publish every 5 seconds. And there's the ramp-up delay. So each producer will start between 1 second and 2 minutes in this case. Okay, not bad, quite easy, but it's not that big. And in this case, we are using about 1,000 threads inside PerfTest. Okay, so if you have a bigger workload to simulate, like 10 times as more for here, you will use like 10,000 threads in PerfTest. That's good. And if you want to go even further with dozens of thousands, it won't scale. So we added some options inside PerfTest to reduce or to adjust the number of threads. When we, by default, we're going to have 2 threads for each producers and consumers. We are using blocking IOs, so there's one, for each connection, there's 1 reading thread, and there's 1 thread for the heartbeat mechanism. And for consumers, we have 1 thread for each consumer, so that's why we had like 1,000 threads previously. But here the rate is quite small, so we can actually use much fewer threads for heartbeats. So here only 10 threads, that's enough. And instead of using blocking IOs, we can use the NIO connector inside the Java client, and here use 20 threads for all these producers and consumers, and that should be enough. Same thing for the consumers. They don't do much in themselves. They just get a message every like 30 seconds in this case. So we just use 100 thread pool in this case. So we reduced here the number of threads significantly with only 150 threads approximately. So we introduce all these options for our own cases actually to simulate some typical customers' workloads. In the next versions of PerfTest, we may come up with defaults. All of this is documented, but it's a bit technical, and you need to know a lot about PerfTest and the Java client. So we may come up with some default values that you can override if you want. So to use much fewer threads. We also introduced some support in PerfTest for metrics. So for example, for Prometheus, when you start PerfTest with the appropriate flag, it will start up a web container and expose all the metrics, especially here. Can you hear me? The latency is interesting for when you want to know about your whole system. And here, this is actually handled by Micrometer again. We currently support JMX and Datadog as well. And then you can build dashboards. That's one dashboard we built with Prometheus and Grafana for the PerfTest part to know more about the latency. We can add also JVM information like garbage collection and so on, and try to correlate this data with the broker data that we have also on Prometheus and Grafana. Okay, wrapping up. So here the point was to try to illustrate where you can use RabbitMQ with Spring and Reactor, so many places. That's a good investment. We try to provide first-class support and integration for Spring, Reactor, and also Cloud Foundry. So that's there's a lot of things already, but that's an effort we're trying to maintain as much as possible. Okay, that's it. We have, I guess, 10 minutes for questions. Any question? Yeah?
Is there a way to guarantee the sequence of the numbers which got on the
The question is there a way to guarantee the order of messages? Is it?
Yeah, we got consumed by the client. So the way it works is that to get a very fast performance, we always use the asynchronous ways to do specific messages instead of the synchronous way. And once we just push the synchronous way,
I can barely hear you. Maybe is there a mic or something? Technical crew, is there a mic that we can, or just speak louder? Sorry.
So by default, how the RabbitMQ handles the performance in a message in a synchronous way. Is there a way to configure something? Yeah. Are you able to hear me now? Hello. Yeah, so my original question is there a way to guarantee the number of messages which got consumed by the client in a guaranteed sequence? So if the publisher publishes 1,000 messages, there is another client which is a consumer side. It also gets all the 1,000 messages, but to get a better performance, we always introduce to go asynchronous wise instead of the synchronous. So the sequence will be like, one message got consumed by the consumer 1, but now the 10th number of the message also got, so it won't be on the, message sequencing way. So I don't know, like, we use ActiveMQ, and by default, the way it works is like, it works as a asynchronous way. So if we don't specify anything in an integration tool like Apache Camel, then it will just consume all the messages in an asynchronous way instead of the synchronous way. Once we plugged in to just consume those messages in a synchronous way, we are having a problem with the performance. So it will hit the performance.
So the question is, when we want to maintain the order of messages, we need to kind of have only one consumer and do all of this with a lock or synchronously.
Right.
Not really, actually. That's as far as I know. Because indeed, if you want to scale, you need, for example, multiple consumers. If your consumption takes some time, the processing takes some time, and so that's one way to scale. And if you absolutely need to have a sequence of you need to process your messages in a sequence. You cannot rely on several consumers. Okay, you need only one.
Yeah.
So one way is to maybe, depending on your use case, trade latency and try to do some work with project like Spring integration or things like that to kind of group your message together and then try to send them to the same consumer, for example. That kind of things up front. But you can lose then some latency, basically. Your message won't flow. There will be more time between the time you send the message and you consume it.
Right. So right now we went through the exclusive consumer as well as the grouping of the messages. But I don't know, like, is that functionality also supports in the RabbitMQ?
Is it also supported?
So currently we use another GMS provider called
ActiveMQ with exclusive.
Yeah. So the same concept also is there for RabbitMQ?
No, there's no like exclusive consumer concept in RabbitMQ. No.
Okay. Thank you.
Welcome. Another question in the back? Oh, sorry, there's someone with the mic. So maybe you first and...
Hey, so you mentioned improvements in network partition handling behaviors. I was wondering if any of those would help with the scenario where you have like a VM hypervisor pausing node VMs to like reclaim resources and getting into that split brain network partition behavior in a cluster.
I'm not sure I understood correctly the question, sorry.
So we frequently get into a situation where like a VMware hypervisor will go in and pause one of the nodes in a cluster. The VM, it'll like suspend it for just a moment to reclaim resources, and that creates a kind of split brain network partition where both sides think that they're the majority. And there's like a little blurb about that on the partitioning documentation. So I was wondering if the improvements to the network partition handling would have anything to do with that or help that out.
So if I understood correctly, the question is, could we handle network partition better? Especially, I think this is what you mentioned is partial partitions, like whereby it's not, you have 5 nodes and they are not cut in half, but some nodes can see each other, but not others. So right now it's a mess because we are relying on amnesia. But this is one of the scenarios we try to address with the effort I mentioned at the beginning in the roadmap. So get rid of amnesia inside our partition handling mechanism and try to handle better cases like partial network partitions. It's not there yet. There's a lot of code base depending on amnesia right now, but this is something we are trying to address for the whole cluster thing. And inside the new queue implementation that we are also implementing, partial partition is something which is dealt with, actually. Okay.
Awesome, thank you.
It's not there yet, but we are aware of these limitations. In the middle? Yeah. Yeah. Sorry, I didn't get the end. Oh, so the question is, I mentioned something in the configuration with configuration changes pushed to the application thanks to RabbitMQ. And how is it different from the refresh annotation? This is actually the refreshed annotation was mentioned in the slide. So this is the same thing, actually. So the refresh annotation, as far as I know in the implementation of Spring, is enforced when there are changes of configuration. So this is the same thing. Another question?
So is it possible to partition a particular queue in RabbitMQ, like similar to Kafka?
Not exactly. So the question is, can we partition a given queue inside RabbitMQ? So not natively, but there's the shard plugin that try to mimic this. So you create a sharded queue, and it's a logical queue. This is what your application sees, and it's backed up by several queues. Okay. In the back, there's some.
What is the optimal number of nodes for RabbitMQ, right? I mean, we were experimenting a lot with RabbitMQs, and some offerings, especially in the clouds, they are not going more than 3 nodes, for instance. What is the optimal number of nodes? And we using lots of queues which are not durable, right? To deliver configuration values to many thousands of instances. How is it going to affect our RabbitMQ, or is it a good way of doing things, or maybe all these non-durable queues move to a different cluster, something like that? Thank you.
So the question is, what's the typical size, the number of nodes that we are using in the cluster for Rabbit, and could using durable queues affect performances in those clusters? So I don't have specific numbers, but try to use odd numbers of nodes, like 3, 5, 7, and so on. We know that most people are using 3 or 5. It's not that much, but not that many, but that's a common size. Common deployment. And regarding the number you mentioned, we know that some of our customers or people we know are running much larger clusters with much more nodes than 3 or 5. But try to stick to something with an odd number. That's good when you get a partition and to reconcile and know which part is should be trusted. For the second part of the question, so durable queues, that was the question, right? Should durable queues affect the performance?
That's correct.
Not really. So I don't know why you are using durable queues, but
non-durable queues.
Non-durable. Okay.
I mean, queues associated with instances, right? Let's say instance goes down, queue disappears, new instance coming up, container, a new queue created for that to deliver configuration values, right, on the fly.
Okay, so you are using non-durable queues, so that if a node goes down, the queue can be recreated elsewhere, which is not the case if you are using durable queues. You can try mirrored queues with a limited number of nodes, like if you have, for some reason, using I don't know, a large number of nodes, 3 mirrors, 2 mirrors should be enough, for example. Because, yeah, mirror queues could be a better solution here than recreate elsewhere. But if you can manage inside your application the fact that a queue is not visible for a few seconds and it can be recreated, that's fine. But maybe mirrored queues is a way to go, at least to try. Okay? 2 questions. Go ahead.
You mentioned some limitations of mirrored queue are addressed in Quorum Queue. Which are those?
So it's a bit complicated, but it's inside the application, inside the implementation itself. The way mirrored queues handle failure is kind of complicated. This is an homegrown algorithm, and all the semantics are not well defined, basically. And first, it doesn't perform that well because there's some kind of ring of available nodes. So the mirroring happens in this node, which is not optimal first. We fixed a number of bugs or inside the implementation, but sometimes it's just a dead end. There's nothing in the original algorithm that can actually is fixable. So that's why we prefer to use something like Raft with well-defined semantics known in the industry to build our new distributed queue implementation. That's one of the reasons. There was another question.
We've experienced where if a channel gets overwhelmed with messages coming in and our consumers can't drain that fast enough, then Rabbit's behavior will start to discard these messages. Now, when this happens, we're not in a position to scale the number of consumers quickly enough. What are the best strategies that we can put in place to avoid the discard of messages?
They are discarded in which way?
Just throws them away. Like as messages get flooded, like if their channel gets flooded when it reaches its capacity, any messages that then come or attempted to be written onto the channel will just get discarded.
So the question is how we can avoid discarding some messages when consumers are overflowed. So they are discarded inside the, what's your question? Inside the client?
They're discarded at the point of being published onto the channel from another publisher.
At the point,
where our publisher is attempting to write to
yeah, go ahead.
The RMQ channel. Because they can't drain. So we've got our publisher, we've got our consumer.
Yeah.
Our consumers can't drain fast, as fast as our publishers are writing to the channel. And these messages will just get discarded.
But so the question is, well, yeah, we have too fast publisher compared to the consumer. But where are they discarded? Sorry, in which place they are discarded? They are not on the broker, on the client, on the sender.
The publisher, the sender. They just get thrown away.
Yeah, it's weird because they should go to the broker because the fact that your consumer is not fast enough shouldn't affect the publisher. That's the whole point of messaging, right? So the broker should be buffering all this. So that's why I'm not sure how they can be discarded at the sender level. Okay. So we can have a talk just after. Yeah, but what will be the? Yeah, that's because in the AMQP protocol, the question is, or the precision is, the sender is messages are lost when they are sent because there's some kind of asynchronous error. It's not blocking. Yes, indeed, they are silently dropped in a way. The basic publish method in AMQP is asynchronous. So that's part of the protocol. So we must deal with it. So that's why we introduced publisher confirms so that you can get an information that the message hasn't been taken into account. Okay. And inside the Java client, there are also ways to exception handlers and so things like that to know about errors, basically. Okay. But we can have a quick chat afterward. Okay, are we done? No, there's many questions.
What's the best approach to relay a message for troubleshooting a client side, the consumer side
Sorry, say it again?
What's the best approach to replaying a message?
Oh, what's the best approach to replay a message? Yeah, so there are different schools for this, but sometimes people are using kind of jobs, asynchronous jobs. They kind of expect a confirmation in a way from a shared database or whatever when the message has been consumed properly. So a flag is set up saying this has been processed, okay? And the sending or cron jobs or whatever will go through this table, and we send all the messages which haven't been confirmed, okay? That's a way to replay your messages. Okay, do you see what I mean? That's one way, for example.
Yeah, but sometimes it just let's say it had the consumer actually throw exception or something, and then you try to replay it right away, which sometimes you're not really ready to. Is there any way to just have it replay sometime on demand from the console? The RabbitMQ console or something. You fail the first time and it just put it somewhere in somebody's queue that it can be replayed.
Oh, okay. So the question is, can it be replayed in somewhere or be put somewhere because the consumer cannot do anything with it? But this is your question?
Yeah, basically it's just mostly for troubleshooting problem. Let's say they work in an environment that something wrong with the consumer side and you doesn't really, if you don't put the message somewhere else, they're going to retry it 5 times.
Yeah. So the question is how we can replay it easily because it's not the right moment for the consumers. There's something not available downstream, and we want to store somewhere this message. So yeah, dead lettering is a good solution, basically. So the consumer can try what it needs to do. It fails, and it then can reject the message. That will go to dead lettering, to the dead letter exchange. And from the dead letter exchange, it can go to a queue where it consumes and resent. Does that make sense?
Yes, but is it possible with the console or something that you have to do how you would do that?
Oh.
Add that back to a queue.
Not exactly from the console, but you can configure something like Shovel, for example, the Shovel plugin. The Shovel plugin could actually get messages from the dead letter queue, from the dead letter exchange to the dead letter queue, and then it can shovel to the original exchange. See what? Something like that. There are other, even more complicated way. You can have 2 levels of dead lettering, for example, kind of dead lettering. You can have, because you don't want to retry immediately, right? So you can have a first level where no one consumes. There's a TTL on the queue. And there's also a dead letter exchange for this queue. So message will sit there for like 5 seconds or 10 seconds, and then they're going to be dead lettered again. And here you can plug your shovel mechanism. Okay, so this way you have like a retry, a replay after a few seconds or any TTL you want, which is all handled by the broker. Things like that. Yeah. The name. The Shovel, that's a plugin Shovel. It's, Shovel is something too. Sorry. So this is quite a popular plugin that we are using. It's just an AMQP client, basically, that you can configure from the broker, and it will shovel messages from one queue to somewhere else. That's it. Any more questions? Thanks for the questions.